我很荣幸呢，为大家介绍下一位发言人，那就是 Chainlink 的联合创始人 Sergey Nadarov。Chainlink 为全球预言机网络设立了标准，为混合型智能合约提供服务，并将区块链应用连接至真实世界的数据。Chainlink 为开发者提供了最丰富的优质数据源和最安全的链下计算资源，可以覆盖任何区块链上的智能合约，帮助智能合约实现更强大的功能。Chainlink 目前为全球许多顶尖区块链上的几百个项目保障了数百亿美元的价值，其中包括以太坊、Avalanche、Phantom、Solana 和 DevNet 等。Sergey 将在他的演讲中分享智能合约的总体发展趋势、智能合约功能的发展历程，以及技术创新将为区块链应用解锁哪些新的功能。他将具体提到一些创新的用例，不仅包含去中心化金融，还包含非同质化通证、游戏和保险等众多新兴行业。Sergey 将重点谈到混合型智能合约如何推动这些发展趋势。混合型智能合约不仅限于所在的区块链，而且能够通过预言机网络访问链下资源。然后，他将深入探讨 Chainlink 如何推动混合型智能合约的发展，专注于开发跨链服务，特别是跨链互操作性协议，来连通所有区块链。最后 ，Sergey 将畅想未来，探讨这种连接性如何推动刚接触区块链的企业和机构进入这个新兴领域。下面有请 Chainlink 的联合创始人 Sergey Nadarov。
Hi everybody, today we're going to be talking about smart contracts, the future of how smart contracts are going to be applied to both various societal concerns and peer-to-peer transactions, and therefore, their individual use. I think one of the main things to keep in mind about smart contracts is how they are evolving in terms of how they're built and all the different areas that they are now covering. So while smart contracts might have started out as a single piece of code on a single blockchain, they quickly evolved, and the definition of what a smart contract is evolved to include many pieces of code on a single chain. So you might have had a tokenization contract as the first smart contract, and then you had multi-sig to secure the contract, and then you had voting contracts to vote on things to do with the tokenization contract. And so this is the architecture that initially defined a smart contract. Now, with the appearance of various financial agreements and in decentralized insurance and various other more advanced use cases, the definition of a smart contract is actually various pieces of on-chain code and various trust-minimized off-chain systems in the form of an Oracle network. And it's these Oracle networks that we focus on and that we provide in the hundreds and soon going into the thousands, providing various validated off-chain data to start, but now actually the expansion has gone on to include various trust-minimized off-chain computations as well. So the definition of what a smart contract is basically continues to expand. While starting out with one contract, moving on to multiple contracts on a single chain, now it's multiple contracts with multiple Oracle networks providing different pieces of data, different computations, random numbers, various inputs that the contract needs. And where we see it going is a continual expansion in both the amount of individual contracts that interact and the amount of off-chain decentralized Oracle networks that provide the various services that smart contracts need to do something useful. We actually see the smart contract definition evolving to include various contracts on various chains, all using various Oracle networks for different types of data, compute random numbers, and so on. So the definition of a smart contract continues to evolve. And as the scope of what people can compose into a smart contract widens, so does the scope of what smart contracts can do in society and for peer-to-peer transactions. Basically, you start to see more financial products and services, you start to see more insurance, you start to see more decentralized foolproof gaming, you start to see a number of various guaranteed, cryptographically guaranteed agreements coming out of these more advanced hybrid smart contract architectures. And that's really our goal. Our goal is to take the hybrid smart contract architecture and bring it into reality through the provision of all the off-chain services, whether that's validated data, trust minimized off-chain compute for DevOps, for random number generation, or even the cross-chain connectivity that's needed to make more advanced smart contracts across many different chains. And this is actually a mimicking of what you see in web world. So in web world, you see many people building advanced web applications out of hundreds of services, right? So there's a ton of different individual services that were built inside an organization, and then there are a ton of different external services to do payments, to do transmissions of messages, to do any number of things. And that's actually what makes the most advanced value-creating web applications. And that's where our industry needs to graduate to. It needs to graduate to a very rapidly iterating, service-oriented architecture-based composition of many different services, some on-chain and some off-chain. And it's this universe of off-chain services that we are continually providing, and that extends from the validation of data to make that reliable enough to be used in a smart contract, to various off-chain computations that smart contracts can't do on their own and need a trust-minimized off-chain computational resource such as Oracle Network to do for them. Now we're heavily focused on moving on to adding cross-chain validation, cross-chain messages, and cross-chain movements, so that you can actually build not only data-enriched smart contracts, not only smart contracts with various levels of computation that a blockchain doesn't give you, and an Oracle Network can give you, and therefore combined with a blockchain allows more advanced hybrid smart contracts, but actually the ability to build smart contracts that are a collection of different services and collection of different pieces of smart contract code across many different chains. So for example, you might want to launch an application that many people from many different chains could use or interface with or send value to, and at the same time, you still want to run the application on a certain core chain for various, scalability or security or whatever other trust assumption reasons. So you should be able to do that. You should be able to not only write your core code and run it where you want to run it, but you should be able to access all the data you need, access all the computations you need that aren't on a blockchain and are still trust minimized and therefore useful for a smart contract. And you should be able to access all the other contracts on other chains and get the benefit of using those, or launch an extension of your smart contract on those other chains in a very efficient, kind of cohesive, service-oriented way. And this is where we see the next stage of this industry going, starting with the provision of data, giving rise to financial contracts, the combination of advanced on-chain data with trust-minimized off-chain compute capabilities that go beyond what a blockchain does and is combined with a blockchain state, and now cross-chain smart contracts. So that's kind of the progression that we're moving along, and we're very advanced in. The next part of this progression is the enterprise and institutional adoption of blockchains, which is rapidly happening for a collection of different reasons. Some of those reasons are the efficiency of blockchains and smart contracts. Some of those reasons are competition. Some of those reasons are user demand and users demanding cryptographically guaranteed agreements from institutions and enterprises. Generally speaking, as we integrate with hundreds of different chains, and we are integrated with the most chains of any protocol that I know of, as we integrate with hundreds of these chains, we basically create an abstraction layer that is an interface for using all blockchains from an enterprise, right? So an enterprise and an institution, whether it's a government institution or whether it's a private institution, they really don't want to learn all the different chains. And if they're a multinational enterprise and they need to interface with many different other enterprises all over the world, they're going to need to interface with many different chains, because in different parts of the world and in different industries, there will be different chains. There will be different chains implemented to do different things, whether that's derivatives or equities or global trade or gaming or ad networks. There will be a big fragmentation for a number of years still, where different verticals have different chains that they gather around, and different geographies even have different chains that they tend to gather around. But enterprises and institutions will need to interface with all of these environments, and because we launch all of these services on these environments, because we launch all of these data-related Oracle networks, these compute-related Oracle networks, we have basically amassed a number of integrations. And those live integrations that secure tens of billions of dollars in value today and power the majority of the financial contracts on many different chains, and the majority of the various gaming implementations on many different chains. Those integrations are time-tested and proven, and they're hardened through collaboration with actually the core developers of those chains, because the core developers of those chains would like those services in their ecosystem. So the maintenance of a Chainlink integration into a chain is actually quite useful for the target blockchain, because it allows them to have many different decentralized services that their developer ecosystem needs. And the developer ecosystem of a chain is actually, the real measure of that chain at this point in the blockchain industry's evolution. So as we continually launch and provide hundreds and thousands of these decentralized Oracle network trust minimized services that power all of these different smart contracts, we also accrue a greater amount of integrated chains that are hardened and maintained by a collection of developers that not only use those integrations, but also even the core development team of those chains that needs those integrations to be properly maintained for all the key services that their ecosystem is getting. And this creates a kind of focal point through which all transactions and all commands from enterprise backends can flow. And this really benefits everybody. It benefits the blockchains because they now have an efficient mechanism to get a large flow of commands and enterprise events. And the enterprises benefit because they don't want to learn 10 or 15 blockchains every quarter. They just want to conduct transactions in the environment that their counterparty would like to conduct those transactions in with them. And so the creation of a single abstraction layer to facilitate that interaction is quite, in my opinion, obvious and very needed, and it's becoming even more needed as we're seeing with our interactions with banking users and insurance users and global trade and trade finance users. There is definitely starting to be a realization that it's going to be a multi-chain world. If you're a multinational enterprise, you're going to need to interface with many different chains efficiently, and this is kind of the really big technical hurdle for enterprises, because of the security and the complexity of blockchains. And that level of complexity is what they traditionally apply an abstraction layer to, right? So APIs are an abstraction layer. A number of other resources that allow people to use various computing systems are really abstraction layers. And so that's really the second thing that's being built alongside the provision of all these decentralized Oracle network-powered services. CCIP is kind of a lot of the culmination of some of this work, where we are defining a global standard for how to message across different chains. And the important nuance here is messaging, right? So CCIP is the cross-chain interoperability protocol. It's not just about moving, any kind of value or tokens or something. It's about actually moving, those things and messages, because messages are actually at the core of how most financial systems and most computing systems work, right? Messages can convey commands as well as instructions about how to move tokens or value. Generally speaking, CCIP is a collaboration between us and some of the top kind of development teams in the blockchain industry in both, various financial smart contract verticals and various even CeFi institutions that power a lot of what's going on with blockchains today, and various other initiatives that want to move a substantial amount of tokens and a substantial amount of commands and instructions across different chains. And one of the real benefits of focusing on messaging is that you actually have a dynamic where you can send whatever you want to send that is going to be moved onto a different chain, but you can actually send the commands of what to do with what you've moved. Right, so you can move some kind of token or an NFT or whatever you'd like, or a central bank digital currency, but then you can also attach commands to that central bank digital currency or token or NFT, and you can tell the bridge what to do with it. And this is only possible when you have the abstraction layer level of messaging. And so the same security that is powering tens of billions of dollars for trust minimized data delivery, trust minimized compute for randomness, for keepers, this same level of trust assumptions and guarantees is also useful for creating cross-chain movements and cross-chain commands. So CCIP is something we're very heavily kind of focusing on. And this is, again, going to solve that key problem of, hey, how do I as an enterprise use many different chains? And the fundamental answer, once again, is an abstraction layer. And this abstraction layer is initially seeded by our provision of services, and now it's evolving into a global standard for messaging about how to interface with various blockchains in an efficient, reliable, secure way, so that enterprises don't need to learn 50 chains. They don't even need a wallet on those 50 chains. They can just send commands into an abstraction layer, a framework, and that abstraction layer and framework can provide them the security, the access control, and in many cases even the consensus needed to guarantee that those commands are going to be executed on a target chain. The target chain's state of a smart contract is going to be monitored, and then there's going to be a return of what's going on back into their system. So they can continue to use their system, their APIs, their existing messaging systems and standards. There's just another layer, another abstraction layer, which is really very common in how systems are built these days. Generally speaking, I think this actually also extends to central bank digital currencies, if those central bank digital currencies become blockchain-based. So as more things become blockchain-based, the abstraction layer becomes increasingly useful in that it allows the interface with all of those systems. Various blockchains for financial instruments, various blockchains for trade finance, various blockchains for gaming, various blockchains for central bank digital currency transactions. From the point of view of the abstraction layer, that's basically all events and messages, just on different topics. And so in addition to the creation of all of these decentralized services, as those decentralized services become integrated, you have an abstraction layer that also forms. Thank you very much for your interest in this, and excited to be meeting many of you at some point soon. Xie.
Thank you, Sherry. Thank you.
我们刚刚听了Chainlink联合创始人 Sergey Nadarov's 的演讲，他在演讲中谈到了混合型智能合约可以为去中心化应用带来的新机会。用一句话总结，那就是接入链下资源可以让开发者实现更多的创新。正如 Sergey 所说，将各种不同的服务和数据类型连接在一起，可以创造无限价值。我们现在使用的一系列互联网服务连接在一起，共同构成了 Web 2.0，而 Web 3.0也会遵循同样的发展逻辑，将新一代的去中心化互联网服务连接在一起。为了推动 Web 3.0的发展，Chainlink 目前正专注于开发 Chainlink 的跨链互遭作性协议，也就是 CCIP。这个协议为跨链消息传输制定了新的全局标准。所以在演讲中提到的一个重点就是 CCIP 对跨链消息传输非常重要。消息是现代金融和计算系统中的核心要素。通过消息传输功能，可以跨链发送指令。在一个生态中，如果可以跨链发送指令，那么区块链之间就可以真正实现无缝交互的通信。Sergey 在演讲中还提到了最有意思的一点，那就是 CCIP 可以将区块链连接至更广阔的现实世界。在未来的多链世界中，企业和机构不想把所有的筹码压到一条链上，但是又没有足够的资源去研究各种区块链。有了 CCIP， 企业就可以无缝接入任何所需的区块链。这个功能将打造出一个良性循环，提升整个区块链的生态价值。这个良性循环就是，随着越来越多的企业接入区块链，也会有更多区块链希望提升自身的连通性。随着越来越多的区块链连通性提升，区块链对企业的实用价值也会随之升高。这些要素结合在一起，最终将使区块链充分发挥潜力和价值。如果大家想进一步了解 Chainlink， 请访问我们的官网 chain.link。如果您所在的企业想要用 Chainlink 进行开发，请联系我。让我们再次感谢 Sergey， 也感谢各位的聆听，谢谢大家。